Swayam Prabha. Digital India. Educated India.
Okay, good morning. So, all of you are from the Tamil Nadu universities. How many universities are you are? You are from which university? So, from each university, one student or how many? Two students from like each college. Ah, okay, it's very nice. So, all of you are now going to go for your second year MSc. First year you have completed. So, do you have any specialization or like in your MSc, or all of you have a general chemistry program? All across all universities. No specializations in the second year. Oh, that's good actually. General chemistry is better than the specialized one. Yeah. So that you will realize later how much it is important. Okay. So, so myself, Professor Beeraiah. So from this department, I am a synthetic organic chemist by research. Okay. So, and I teach organic chemistry courses. So you can see my website. Okay, in the department website. So and see our research activities. What we do. So we do work on all kinds. You guys know, right? Carbon-carbon triple bond based functional groups. You can just find out more. So I am more interested in doing this green synthesis. So we will see. This is the course I floated. This elective course. Usually our second MSc students will learn. Okay, in the fourth semester, this elective. Okay, most of the students will learn this. So where I teach the green chemistry principles, then their applications, what it does actually. Okay. So how many of you know the green chemistry term? Have you heard about this? Raise your hands. No, no half of full. Huh? Just now you had tea, coffee, right? So most of you know. So where? In your bachelor's or this your MSc? Where? Bachelor's. How many of you are from bachelor's? Means when did you in your bachelor's you heard? How many of you are? No, just want to know because it's very important and a lot of students know. Means even universities, colleges doesn't have this syllabus actually. It's very important. So only you. Okay, and remaining all are in your MSc. So you had this content in your curriculum. So where you learn which course? But in the first year you don't have electives, right? Huh? First year itself will have electives. Oh, that's good. So which means in the first year also you will learn some specialized courses depending on your interest. Oh, that's good. So what do you learn in green chemistry? And this is a full course or a small content you learn? 1-2 classes. Suppose you tell me. So you learned like I said a full course means the throughout the semester or only 1-2 hours you learn. Oh, that's nice. Then I don't have to teach too many things, basic things. That's good. So doesn't matter. So that may be a very general chemistry thing. But today I will teach you the principles of green chemistry in a very general point of view. But since I am an organic chemist, so I will be touching more on the organic examples. So whatever the principle or whatever we learn here in terms of green chemistry, so I will give you the organic chemistry examples. If the same principles, suppose a other teacher who is expert in physical chemistry give you, he may pick up more examples related to the physical chemistry and explain same principles. But doesn't matter. The concept is same. Only the examples will be slightly different, and as I said, the course is also green organic synthesis because we do a lot of synthesis. Okay, and why we need to learn is also very important. That maybe I have another class on Tuesday. That day I will tell you after learning these things why I am more interested in this organic synthesis. Okay, you will see. So this is some syllabus. Okay, this will be there in our department website also. Okay, so you can figure out. So what our students will learn in this course. Okay, this is like a basic introduction thing, and there are some topics they learn. Okay, And mostly the next class I will be touching upon these three topics. So where you actually see the real application of green chemistry principles, okay, how they actually guide us to develop some new innovative synthetic methods and reactions, okay. So there are some books, that's okay, that's all about the coursing. Actually I should remove this, okay, but doesn't matter. So I edited some slides, but most slides are still have this number. So why I was asking you people is about the green chemistry. You can see that this slides, there was an article in 2020, okay, Journal of Chemical Education. Okay, if you don't know about the journal, just go log in and check. Okay, Journal of Chemical Education, where you find lot of the academic related research. Suppose you do lot of experiments in your PG labs, right? So that is inorganic, organic, so those kind of experiments will be published here. It's not that advanced research or anything, but it's like education related research experiments. You do some synthesis, some aldol reaction with some two reactants, any two reactions you can take. So somebody will actually do the reaction step by step. They monitor each and every procedure, okay, from the time they take the solvents to the until they get the final product characterization, everything, the systematic procedure will be reported in this journal. It's a very useful journal for academic purpose, not for the research. So what it says is, the title is Green Chemistry Coverage in Organic Chemistry Textbooks. It's not only for India. This is the international journal, and this talks about the across the globe how much students will learn about the green chemistry at that point of time. You see that there is a nice image. So only less than 1% of organic chemistry books or most of the chemistry books will cover about this green chemistry. Of course, these days now things are getting better. Okay, so it's very important to learn the green chemistry, but lot of our curriculum doesn't have this. Okay, and you are supposed to learn actually in your bachelor's. Okay, so I learned only after joining here. That's a different thing as a faculty. Of course, our things were different, and we were not in need of green chemistry. But now you people need the green chemistry principles. It's green chemistry is nothing like anything like magic or anything. It's just some guidelines. Okay, how to do a better research. Okay, and how to make things better for your society. That's all, nothing more than that. Okay, so that's what this says, and that tells the current status of the green chemistry, how much, not only for students, even the researchers, how much they are aware of these green chemistry things. See, today I am telling all these things. Okay, maybe 10 years back I was not aware of this. Maybe I have a green chemistry, there is something, but I don't know what it is exactly, okay, how much it is useful. Okay, but it's important to learn every person, whoever is in research, whether it's a chemistry, physics, engineering, doesn't matter actually. Though it comes as a green chemistry, that title, but it is applicable to every researcher, every industry who deals with the materials, any compound. Obviously, if you say any industry will work with materials, right? There is a plastic, your pesticides, medicines, your steel or metals, anything. These are all materials only. So as long as you are working with materials, you need to learn about this. Okay, but you may be wondering, sir, you are telling that this is very, very important for every field. Doesn't matter, engineering, maths, physics, chemistry, everything. Okay, but why it say we call it only green chemistry? Why can't we call it a green science, green engineering or anything? Have you thought about this? I am just telling that it is useful. Everybody needs to learn. It's not you and me. Everybody. Even computer science students needs to learn this. Though in terms of, not in terms of chemistry, but that concept of the green chemistry, what we are principles, what we are going to learn, that concept they need to understand. As long as actually you are utilizing a materials or you are synthesizing materials, I am telling, you need to learn. But the question is, why only chemistry? What to do when it is applicable to, universally applicable, but you are actually not, the title is narrowed down to a one particular subject. Is it telling you something? It tells that chemistry is actually everywhere and is everything. If you can work with the chemistry, if you can control the chemistry processes, chemistry properties of materials, or okay, this one properties, actually whatever you are looking at the different fields, you can control. So, which means origin is from chemistry and solution is also from chemistry. That is why though the applications are everywhere, but where you should solve the problem? The beginning. Where is the origin of the problem? There you should do. So, which means chemistry is the actually origin of the problem and chemistry is the origin of the solution also. Okay, but applications are everywhere. Okay, right? So, if somebody uses a water bottle, plastic water bottle is throwing. Okay, he doesn't have to know the chemistry or physics. He doesn't have to be like a scientist or a educator or anything, right? Anybody can use and throw. Which means once you are throwing a water bottle, he is actually spoiling the environment. So we can tell him that, hey, don't throw, you means add into like a recycle bin, okay, somewhere, or give to somewhere this one, okay, don't throw even in the water or anything, so that it can be recycled, reused, this one. That much only he can do. But what we can do is, we can change the property of the bottle material. Even though somebody unknowingly throw into the environment, should not be any problem. That we can do. What he can do is, he can only say that he will not be able to throw, means he should not be throwing anywhere, right? That much only his contribution. He is not into the properties of the materials or anything, right? We know what is the problem with the plastic, and so that is our responsibility. So like that, the user is different person, but he doesn't have much control over the consequences, are good or bad, consequences of that material. So we have the more control. Okay, that's why the chemistry is very, very important in controlling lot of things, particularly the pollution, environment related things. Any engineering or science, most of them will work with only materials and their properties. Nobody will synthesize the materials. Okay, the material synthesis comes from the chemistry only. This all of you should remember. Okay, so that is why we need to learn the properties only. They will study and say this property is not there, this is there. But the corresponding material, who will synthesize? Only chemist will synthesize. No physics person will do the synthesis. No mathematics or no engineers will do the synthesis. Somebody chemist has to supply the materials to them. They will actually fine tune the properties, test this one. They say that, hey, this material is not good, so we need this combination of material. Can you synthesize? Even the biologists, they don't synthesize. The pharmacists, who will synthesize the compounds? Chemists only, right? So that's what. So we have a more role in the controlling all these things. Okay, so that's why they said application is everywhere, but the control is with the chemistry. That's why it's still today it is green chemistry. No green physics, green maths, green engineering. No, you don't learn all those things, right? So you learn as a green chemistry, and you learn everything about environment, society, everything. We are not directly related to that, but actually indirectly we are responsible for that. You got it, right? Yeah, that's very, very important. Okay, maybe having sir, why only green chemistry is not narrowed down to one particular thing. Remember this, it's a universal and everybody needs to learn this. Okay, you can go and tell to your MSc physics friends, if you have our biology, tell that, hey, you need to learn this. Now it's very important, I am telling you. Okay, so this is simple thing. Okay, so why green only? Why not red, blue? We have many colors. Simple. Whenever you see the green, okay, color, when you say that talks about the nature, purity, pleasant, freshness, many things. So it's a very happy feeling, a comfortable feeling, and particularly it goes with the nature. Anything with the nature, no harmful. Okay, that's what you should learn how to mingle with the nature. Then in that case there is no problems at all. When you are actually deviating from the nature and its properties, all these floods, cyclones, whatever, landslides, everything happens. I am telling you, it's a fact. Okay, so what happened? What is the problem? It's a different, but that indicates that you are actually going away from the nature. Okay, so you need to mingle with the nature to keep the things or society or your environment, okay, safe. Okay, so why are we learning about the green chemistry? Okay, after 5 minutes I will go there. So that is all about some introduction about the green chemistry, but why we need to learn? So what to do with the green chemistry? It's different. So but generally, what is our aim? You are doing your masters. Suppose you are doing your masters. What for you are doing? I am working here as a faculty. My native is in Telangana. Okay, from there I came here and I am working here. What for I am working? Simple thing. Okay, you get a master's degree, what you will do? Suppose you had 2 years back, you had your friend is there having a bachelor's degree, and after 1 year you will get a master's degree. What difference you see? Speak out, don't worry. Let it be a wrong. It should be your own personal opinion, but let it be a wrong. Somebody may not be accepting your opinion. That's okay. Don't worry about it. Okay. So we are not here in this class to say right or wrong, to discuss and to learn something new. Okay, don't worry about this. See, I can teach without getting a PhD and without coming to IIT Madras. With masters also, I can teach to my +2 students. Can I come and teach IIT Madras? But now still after as an IIT professor, I can go to and teach even school kids also. But they cannot come and teach here. No, I am just telling that degree wise, okay. Okay, I am not putting them down there. Okay, that's it. They have their own way of handling this. But I am telling is the practical utility of your degrees. What it means? You are going to go better position, a better life. Everybody, whether you or me, that's what we need, right? So you want a better life, particularly than your parents. That's what your motto of your parents, any parents, right? So they think that they think that my kids should not be in my same situation, because it's a next generation. It should be some advancement in their life, okay, in their comfort, right? That's the motto. For that we will work. We will do everything, right or wrong? Studying and writing exams and working, agriculture, whatever anybody, whatever does, it's for betterment of our lives, to make our lives comfortable, right? Okay, that's what means a sustainable society, a happy society we want to build. That is the main goal of either you set up an industry or you study or you do agriculture, anything across the globe. Anybody does anything. You know, somebody is going to now the Mars, okay, moon, all those things. What is that? They want to settle there, okay, they want to establish, they want to learn the environment there, right? There is some betterment. Of course, they have their different visions, but they feel that that is very comfortable for them, right or wrong? For everybody, the idea is to have a comfortable life, that if you put them together, all the people, all the society, that's what called sustainable society. Okay, okay, it's a comfortable society. But what is only if you are happy? You think that that is only sustainable society? No, everybody should be happy. Not only humans, the other creatures also should be happy. Environment should be happy. Everything should be happy. Then only it is called sustainable society. That is why I say ideal. You learn in your physical chemistry ideal gas and real gases, right? So you know how difficult it is to achieve the ideal gas situations. So reality is different. But here also there are difficulties, but we can achieve. So there is an ideal situation we want to achieve, and when you get that situation is meeting the needs of the present generation without compromising the ability of future generation. It's not that you should be comfortable, but your next generations also should be comfortable. Not only immediate next, several generations. So there should not be any problem. Whatever the comfort you want to have in your generation, the upcoming generations also should be having, and that's what you should do. Once you achieve that in terms of anything, and then you can say that it's a sustainable society. Sustainable means what? It exists forever. There is no compromise, right? It runs for long time. I can say unlimited time. That's what sustainability. Okay, it should sustain. You say that it should sustain, which means it should live, it should exist. So that's what it is, and the possibility that human and other forms of life on earth will. It's not that only humans, I said, even other creatures, other lives also should be there. Without trees, without animals, you cannot live. That is not a sustainable development or sustainable. So we need to achieve all these things and enough for all. That's what I said. Okay, whatever you make, money or other things, okay, materials, okay, pharmacy or drugs related, anything you want to have, and agriculture, food, it should be there unlimited. It's like a reservoir. Just go and take, and there is no end. Okay, so it should be like that. So then only you can say sustainable society we are achieving, but it's a long time goal. Okay, so as of now we are not into that, and for there are some things, okay, just overall that same thing only. So but what can we do to achieve the sustainable society? Make sure everybody gets the food on time, okay, there is no starving, and water will be there good, okay, and sufficient money will be there, all those things, which means everybody should start working, okay, in their respective capacity, okay, and they should start earning money and make things better, right? Some job needs to do. That's where this industrialization has come about 50 years back, 50, 60 years. Not only whatever I'm talking, not only in the context of India, I'm just talking general thing. Don't worry about, okay, I may take some Indian based examples to, but it's not limited to India. It's everywhere, general topic, okay. So what people thought is, okay, let us set up industries. Even now also you hear, right, when the elections comes, politicians say that, okay, we will set up this industry, that industry will give so many employments to people, okay, which means when you set up an industry, obviously we need employees. So which means some families get job, okay, they think that that will help the people to better their lives in a positive sense. But the other way, if you look at, apart from giving the jobs to the people, what does that industry do? Air pollution, water pollution. That's why a lot of places people fight also that we don't want these industries. At least these days people are fighting that when some industry is going, government is going to establish some industry, people are these days aware about that consequence of that industry, and they are fighting that we don't want here in the nearby. Right? This is a lot of times we hear in news. So because all these things happen, to establish the industrialization, you need to do a deforestation that result in a water pollution, air pollution, all these things. And this happened already. It's not that if one more industry comes, it will do. It's already happened, and people are worrying about how do we get rid of all these things like plastic. Now we are worrying, right, how to get rid of this plastic because it doesn't decompose. Okay, I will come back to that. But what I'm telling is, the industrialization people that, okay, that is the one solution to achieve the sustainable society, or to make sure everybody gets whatever they want, okay, in their respective capacities, and this has done. They have done this across the globe. But now that resulted in all these things. You can see that. First, that's what I said. So I'll take only Indian based examples, but it is applicable everywhere. You can see that so air pollution, source of emission for air pollution, how much? Industry contributes more than 50%. Any industry. I am not labeling any particular industry. Any industry, when you say industry, that contributes 50% to the air pollutions. And remaining transportation, see that 27. This all together about 80%. Transportation, and that's what you may be having that lecture, right, from Professor Raman. He explained what he explained you, Professor Raman. Some batteries, battery technology. Did he explain? Yeah. Now even these days you see here like a hydrogen-based vehicles, electric vehicles, all those things, because where they doesn't produce any carbon-based pollutants, carbon dioxide. This one. Otherwise, this our traditional transportation results in 27% of air pollution in the form of carbon dioxide, carbon monoxide. Now we want to get it up, but I'm just giving you how much it is. Huge. That's what I said. Industrialization has a major role in polluting the air. And this every year we hear in like now in the summer, right? After 3 months you will start getting these news articles that in the northern part of the India, the fog is there, a lot of accidents happen, the air is not breathable. Okay, all this routine, right? And you can see that how many states are there. I think there is some index. 13 out of the most populated cities across the globe are in India. Across the globe. Okay, so of course we have the reason for it, but I am telling it's a problem of everybody's and every country's. Okay, and not only this, again still air pollution, and not see that what else the air pollution does is it results in acid rains also, because it makes the carbon dioxide, carbon monoxide, nitrogen based oxides, everything it will actually emit into the environment. And when the rains comes, okay, because now it's not only the water, you have a nitrogen, sulfur, or carbon based gases in the air, and the water and that they react and they result in the sulfuric acid, nitric acid, carbonic acid, all those things. That's what you call as acid rains. So the acid will be generated in the environment itself when those gases reacts with water. And those gases we are only emitting through this all this air pollution. Okay, and this is the water pollution. No need to say. If you just walk across the street, you will see, right? And you all will okay block your nose and walk, and you scold someone that somebody thrown. But you also do the same thing in your street. And just joke, right or wrong? So means we should be responsible. This is what it's not. We cannot only blame the industry. Even personal hygiene also we are not following. Okay, not we in the sense not only Indians, everywhere. I was there in US also, I was in Germany, I was in France. So we have seen problems are there everywhere. Don't worry, okay. So, and this is another problem. Plastic. You go to the Marina Beach, this Gandhinagar beach, first what you see is, before sand you see the plastic bottles, right? And you say that when you are entering, you say that, hey, everybody, what is this plastic bottles, plastic covers, and you scold somebody, okay? And you purchase a water bottle, and spend 1 hour drink, and while coming you throw there and come. This is true or not? Then when you are scolding, you should remember that somebody else will scold you, right? So you should be a bit responsible, okay? So we cannot just blame the others. I cannot blame you. I should also take some responsibility. Okay. So what I'm telling is, this is what is actually happened with this industrialization, and their products. And you see the deforestation. Obviously, to establish your industries, see, to establish an academic institution, we don't need to cut a lot of trees. And of course, we grow. But to make the industry, they don't bother about all these things. They do take up some forest, and they doing this deforestation, cut the trees, and they start establishing. See, we have seen IIT Madras campus, right? How green it is. We and the deers and monkeys, they move around here and there. So how much, how safe they are, right? So which means at least we are thinking of preserving the human life and the other creatures. Okay, then that should be done everywhere. Then things looks fine. It doesn't matter how many institutes you establish, how many industries you establish, it doesn't matter, as long as you are looking around and make sure the result means the products are not contaminating the environment. Okay, but these are all happen, and you guys know the greenhouse effect. Even this also happened because of the industrialization. So all the consequences of industrialization. Okay, so this is the greenhouse effect. How many of you know the greenhouse effect exactly? What is the greenhouse effect? Any gas. Whatever the gases you liberate, there are greenhouse gases. It's not that we actually liberate. There is a particular concentration of some gases in the environment. If that concentration is maintained, there is no harmful to us. Actually, they will help us because they filter a lot of radiation from the sunlight. Okay, when it is some particular concentration, but if the concentration is more, which how it happens, naturally there is a concentration, but because of your the air pollution, the gas concentration will go high. So what it does is, you see that whatever there is some light comes and they will absorb some light, they react, they do. So there is some balanced chemical reactions happens. As long as that happens, no problem. But if you have more gases, the whatever the light comes to the earth, okay, and we will earth will also be plants and everything will absorb some energy, and the remaining energy will go. The light should go up to the environment. When it is going, if the concentration of this greenhouse gases, so-called greenhouse gas, is more, it doesn't filter. It will not allow them to go, because different energy levels, energy frequencies, wavelengths, so they will block that energy. Okay, the sunlight, that light remaining, where that it goes, it will come back to the earth. You see that? That's what the global warming. So that excess radiation, which actually the earth does not need, still it is coming back. It's supposed to go to the environment, space. So if the concentration of those gases is more, and that's what is going to happen, and that's what the greenhouse effect. Okay, so those gas concentration should be the ideal, okay, and otherwise all these things happens. It's a simple principle. Okay, you need to reduce the emission of those gases. Okay, nitrogen, everything. Don't think that there something is good or something bad. Anything in a particular concentration is good. After that, everything is a bad. Okay. Yeah, so this we see that last year that the Wayanadu landslides, all this because of the deforestation only. Okay, so the overnight 2 villages vanished. So all these things we say that, oh, this happened, but again we start doing the same thing. So we should be looking into all these things, and the main reason is industry, and apart from that you start accumulating all this waste. Everywhere you see that waste is accumulating. This all happened and it's a problem. So what to do with that? This is the current situation. Of course, even today it is there. The people started thinking about all these things about 10-15 years back across the globe. Okay, but even then, till today, still problems are there. We don't see anything properly organized, right? So, but what to do? So, how do we solve these problems? See, we cannot compromise on establishing industries. We need industries to get the materials or the items, whatever food items, the regular chairs, anything, any item for a comfortable life. Because in the beginning we said we need to achieve the sustainable society, sustainable life. That we cannot compromise. That is our ultimate goal. Okay. To achieve that, we need, everybody should be comfort. We need to have a happy life. And for that, we need all these things. But if you do these things, then we are spoiling environment. So how do we balance? So the balancing should be there. Okay, before thinking releasing a product into the society, we should think about its consequences well in advance. Not only in today's context, even after 50 years, what it's going to do, the byproducts, everything. And if you have that thought, where it is a small molecule, big molecule, larger peptide or anything, I'm telling any material is going to come before releasing into the society. If you think and find out its solutions and keep that whenever it is required, like in some movies you see that, right? Some I don't know, some mythological movies. Okay, some treasure will be there, but its key will be somewhere else, or some ghost will be there, but he is how to handle the ghost, and this one there will be something written and written. So the problem is there, its solution is also there, but it's somewhere else. So you should have that solution written, kept aside. Whenever the problem arises from there, you should apply this. So without the solution, finding the solution and having the solution, if you release out, then it's going to be a problem. Okay, that's what we have not done so far. So now what chemistry does in this case, we have learned, see, if you have seen that, it's a very general problem. Nothing to do, it's not that only chemistry student problem. It's a human problem. It's an environmental problem. What chemistry does here? Why we need to learn about the chemistry? Okay, because whatever you say so far, industries, materials, properties, products, everything, name a thing, it's after all a chemical entity. Only the molecular structure is different, molecular formula is different, okay, the way you use is different, utility is different, but everything is a chemical entity built by small atoms, chemical atoms, right? So the atoms you learn only in chemistry, nowhere else, right? So you learn whatever you say, anything in the environment is a chemistry. So if you want to make a sustainable solution and sustainable environment, you need to work with it. This is all we have synthesized, but everything, leaves, food, whatever you name, water, everything is a part of chemistry. Alright, so that's why the green chemistry thing comes. And in the beginning also I said, why to solve this universal problem only chemistry need to be understood, because it is everywhere. Okay, so before doing all these things, that's where you are emitting all these gases, making water pollution, air pollution, all these things, to prepare all these things. We need all these things to make ourselves comfort. That is one part of your sustainable development. Fine, but while doing this, you have developed other byproducts also, other pollutants also. So we need to look into that. Okay, and not only that, even your biological system. It's all whatever you have seen is about materials, but in your health, when it comes to your body health, your okay, even that is also part of chemistry only. Everything, small molecules, larger molecules, but everything is a chemistry. So if you say that DNA structure, this one. So now the biotechnology people do this editing of peptides and DNA structures to induce their required properties in a biological system. You have seen the Seventh Sense movie, right? Surya's Seventh Sense movie. I don't know how many of you are born. It was in either 2004 or 2005. Okay, it was a very nice movie where they edit the DNA to replicate to create the same DNA, so that he can get, once you create the same DNA, he gets all his strengths. I forgot his name. Bodhidharma, right? So the same thing, what I am telling is, which means it's all about a chemistry. Right? Though you are talking in terms of in a different context, but it's all about a chemistry. You are doing a small chemical reactions. How do you change the DNA? So replace one molecule by another molecule. It's engineering, right? But it's a biological engineering for utilizing a chemical entities, right? So that's what it is. So there is nothing is individual. Everything is nicely interlinked thing which we don't understand. Okay, and even our body also has lot of elements. So which means now you see that everywhere chemistry. Okay, now you should feel very proud of yourself that you are actually studying chemistry. Okay, because you can be a good solution to all these problems. Not only this, in your future problems also. Atom bombs, nothing but chemistry only, right? We were scared about a month back about the war and other things, right? Still the Ukraine-Russia war is going and all the bombs are. It's all about chemistry only. People only there. You have seen that Oppenheimer movie? Oppenheimer movie only. It's about the atom bomb only, right? Yeah. So I'm just telling you. So which means we are helping the society, at the same time we are also spoiling the society. And chemistry only. It's all about. Okay. So that's why we need to learn some good habits to do a good chemistry. That's what the green chemistry principles. It's nothing, there is no magic, no mission, anything. It is the only a guideline, a book. There are several principles written. Say that, hey, you need to follow this. If your process or your methodology, your product, anything, try to be fitting in these guidelines. Which means the bad consequences will be less. That's all the green chemistry says. It's not like a magician or anything. It's only a small guideline. Try to fit into these kind of principles before you deliver a product into the society, and that will minimize lot of problems, and that's nothing but the green chemistry 12 principles. Okay, that is what the origin of green chemistry. Yeah, so it is actually originated in 1991. What is originated in 1991? The green chemistry term. Remember, it's only the green chemistry term originated in 1991, not the thoughts. People are aware of these thoughts, everything, okay, in the before also. Okay, it's not that green chemistry means all these pollutions, everything started arising only in 1991, no. Ages back, people are worried about all these things. Only thing, nothing is written. If you don't have a written thing proof, what is the proof that okay, there was some discussion, right or wrong? So only the term was invented by Paul Anastas. That's why he is called as the father of the green chemistry, and that term came about 35 years back. Okay. So, but again I am telling you, always remember, I always tell you, it does not mean that green chemistry thoughts or processes are actually originated only from that point of time. They are there. People are working in industries, academies, okay, they are discussing, but a documented, okay, has come only from this term. So people started using that word and those guidelines, or you can say principles. Okay, that's what he proposed, the 12 principles. Okay, but doesn't mean that the individually everywhere it is there. Just put them together with his understanding. That's all, nothing more than that. Okay, for example, I will give you one example. Diels order reaction, right? You learn. It's a 4+2. It originated from. No problem. After 10 minutes, we will take a break. Okay, we started late. So green, what is that? Diels order reaction. It's a 4+2 cycloaddition reaction. Okay, actually before the Diels order discovered that 4+2 cycloaddition reaction, about 100 years back, the reaction is known. The concept of that reaction is known. None of you know this, right? Right, I am telling. But the context is known. What Diels and Alder reported is this. Okay, but the other one was known. This was this. This is the functional groups I am talking. E9 and alkyne. This is also a 4+2 cycloaddition, but it was not named as a 4+2 cycloaddition at when it was discovered. The products people have characterized, people know what was the compounds and how they originated. They propose that okay, the electrons are moving here. It's not exactly like what they proposed the mechanism. Okay, but this reaction is known about 100 years before the Diels order known. But unfortunately now we are calling only Diels order reaction of the. That's what I am telling. Doesn't mean that when 1991 he proposed green chemistry, doesn't mean that these principles were not there before. Okay, only they were not documented. Okay, you can go back and search about this. It's very important reaction. Okay, just telling you. Okay, so what the green chemistry does and what is the motto of green chemistry is, this is what. There may be a lot of text here, doesn't matter, okay, you read, but the motto of the motivation for that all this text and green chemistry is this: reduce waste, reduce energy usage, reduce the cost, reduce the materials use as much as, don't use the materials even if you don't need, like when you don't need a fan, electricity, when you are going out of the house, you turn off the fans, electricity. How many of you do that? When you go out of this room, how many of you turn off this? Of course, there are other people to do, but generally I am telling you, when you are coming in the morning 9 o'clock, okay, this second floor, right, this is, you see always this corridor light will be on. How many of you noticed? You will be here for another 10 days, right? See that these corridor lights will be on even at 9 o'clock also. Because most of the time I will only turn off. That's what I know. Because when I come to 9 o'clock, I will turn off these lights. I tell my students also, means you should have that. Why the light is required after 6 o'clock? So this all adds up. So save that energy, reduce, okay, hazard and risk of materials, non-renewable materials. So means try to minimize the usage of non-renewable, which means if any material after usage, you should be able to reuse or renewable or convert into something else. If that is not there, try to minimize the usage of such materials. Don't use them. Okay, and environment, just assess the products, environmental impact, how it is going to impact the environment, which way, not only our human health, environment. So that's what the green chemistry says. The total green chemistry principles motto is this, as just a simple compilation. Okay, we'll see what are those principles, but their motto is to do this. That's what the green chemistry tells you. So now you will, if you correlate this, take these properties and try to discuss about the pollutions, all other things, you will have a solution. Okay, so you will see that you are going to have almost all the solutions for the problems what you created so far by doing this. It's a practice we need to get. and once you get that practice, you will have the solutions automatically. It's like you feel that suppose like I have tummy and I have my overweighted. I should start practicing going for walking and doing some food controls, all those things. Then slowly, that's what this guidelines. So doctor says that hey, you need to reduce the weight, you need to stop this food, that is, it's a guideline like grain chemistry. It's like doctor, it will tell you this is, whether you do or not, it's up to you, right? If you come and practice at home, then you will be getting better. But the guidelines exist, doctor exists always. Even if you go after 1 year also, you will say the same thing. So you start practicing. Otherwise, it's of no use. Okay? If you attend a green chemistry class, it's not going to help. Learn and start implementing outside. Slowly, small things, small steps. Then you see the solution. Don't worry about others. First start doing it by yourself. Let others, whether they do or not, that's up to them. But you start doing small things. Don't stop eating sweets in 1 day only. No director will, no doctor will tell you that even if you have sugar, they will, because that is a big problem. If you stop 1 day, they say slowly, step by step, you reduce this. Nobody will ask you to reduce the 5 kgs in a day or in a month or so. They say that gradually you decrease, right or wrong? So like that, you should start practicing. Even here, green chemistry also. So he is the person, father of the green chemistry, Paul Anastas, is still there. Okay. So who compiled all these principles and these are the green chemistry principles. 12 principles of green chemistry. Okay. What it is? First, prevention of waste. But all these 12 can be combined into that 6 summary of the 6 things. Okay. Atom economy during synthesis, less hazardous chemical synthesis. I think you will get these notes. Did they say? No? But anyway, if you want, I can give, that's not a problem. Okay, I will ask Professor Amberson. Okay, at least this is a very general thing. Okay, I don't have anything which I have a patent or anything. It's I want everybody to learn. Okay, so there is nothing like, okay. And if you people give your email IDs also, I will send you. I have no problem. And designing a safer chemicals with less hazardous, safer solvents and auxiliaries, design for energy efficiency, I told you, use of renewable feedstocks, reduce derivatives during synthesis, catalysis, design for degradation, real-time analysis for pollution prevention, inherently safer chemistry for accident prevention. After reading all these 12 principles, what did you understand? A general impact is the 6 things I have shown, 6 or 7, that's okay. But as a chemistry student, now let's come back to the chemistry part. Okay, as a chemistry student, and you said all of you are general chemistry students. Okay, very happy for that, because if inorganic, organic, then somebody says, no sir, I don't do the synthesis, I don't know these. So now it's good that all of you are general. What did you understand from all this? What is common in that? All these 12 principles. Something is common. How many times synthesis has come? Synthesis word has come. 1, 2, 3. Catalysis. It's about synthesis. Okay. Where is this? Solvents is for synthesis. Right. I am talking about a simple chemical reaction. I am making it right. You use solvents also, right? And energy, heating and synthesis. Renewable feedstocks, starting materials. That's what about it. You start using a renewable starting materials. So you need a starting materials to perform the reactions. That's also synthesis. Atom economy, that's okay. Prevention of waste. Try to minimize the byproducts in a synthesis. You see that, and designing safer chemicals with less hazardous. Designing means you have to synthesize. Synthesize them. Synthesis. If you see, everything talks about mostly, not mostly actually, everything. This real-time analysis for pollution prevention. That means that you monitor the reaction carefully. Don't leave for over time. So that you will get efficient yields and other things. That's what I will tell you, explain, okay, next hour. Okay. But I am just telling you, if you see this, the common thing is about the synthesis. Synthesis of what? Materials. Small products, larger products, everything. Now you understand why the chemistry is important? Yeah, because it's all about the material. If you control, means that's what our like in village and everyone, our elder people say that the basement should be very strong enough, okay, to get a better life of your house. So that's what it is. So basement is now the chemistry, and particularly the material synthesis, preparation, everything you have a more control here. If you give a right material to a right engineer, right technologist, he will give the product, the component, the object, okay, whatever the item, whatever you will be using, so he will be giving it better. So even if you throw outside, no save. So he is not controlling that, right? And not the person who is using, he is not controlling, but the person who synthesizes the material controls, right? So you need to give a better material to the right person to give the right product outside. You may not be the right person to deliver the product in the required. I am not we are not making the chairs, right? And the person who makes the chairs, he is not the one who is synthesizing the material, right? Yes, so there, but different. So we cannot blame the person who supplies the chair, saying that this is a polluting the environment. No, he is not responsible for that. Who is responsible? The person who is making the low quality material, the synthesizing the low quality material, he is responsible. He is not supposed to give the low quality material, synthesize. When the material is there, whatever, then he is converting it into a required shape and delivering. That's all his role, that the mediator, the different levels, right? So we are responsible. Who is synthesizing the material? So if you address that, if you synthesize only the good quality materials, synthesize following these, then most of the things you get. And all these principles, if you implement in a single chemical reaction, you will see that this is the ideal, I can say that is something called ideal reaction. You will get zero wastage, zero energy waste, no pollution by solvents, okay, the good properties, no toxic products, all these things, everything is included here, you see that. Okay, that's why we need to learn. These are only guidelines. They say that when you are designing a reaction, make sure there is no byproducts are formed. That's what the first rule is saying. And make sure you utilize as much reactants as possible into your product. Okay, I will explain you. And the product should not be a toxic. That's what it's telling. And as much as possible use the safe solvents, low energy, and make sure you use the renewable, which means the starting material should be renewable. Means there is no limit artificial compounds. Anytime if you want, you should be able to get. Renewable means that kind of reactions. That means that there is no shortage. Otherwise, once you make a product and release out, and the next time when the people need more, you don't have a precursor to do that, prepare the material, then the demand goes up. And that is not the goal of sustainable development, sustainable society. It should be reachable to everyone. So that is a part of sustainable. So you need to link everything to that final goal. Right or wrong? If it is a very expensive, who will buy? Only few people will buy. Then that which means the product is of no use. Everybody should be able to assess the benefits of whatever the invention you do. Right? So that's all, which means you should have a unlimited source of your materials. Okay? So that's what it all tells you. Okay? So we'll take a small break. We'll come back and learn about the 12 principles. You have learned? So far is good? Yeah, this is a very general lecture, but it's very useful lecture. Okay? So though I am a synthetic organist, you have not seen anything synthesis here, but it's very, very important. Okay? Why we need to do? Okay?
SwayamPrabha, Digital India, Educated India.